Okay, so here we have another video for chapter 1. This is section 1.2. Again, these first 3 sections in chapter 1 are all just about basic things about functions and their graphs. So in this video, we're going to talk about domain and range. And hopefully, guys, these are a review, from the previous years in your math class. We're going to determine, first of all, we're going to define relations and functions. And then we're going to look at some graphs and that represent functions, and then we are going to evaluate functions. So a whole bunch to do with functions and their graphs, which is why this is the title of this section. Okay, so let's first talk about relationships. Okay, relations can be about any two quantities. This is literally just the relationship between high-paying celebrities and their earnings. It's just two different quantities and their relationships, how they are related to each other. So it doesn't matter whether we're looking at celebrities and earnings or numbers, that is a relation. A relation is any set of ordered pairs. Any set. There's no specifics about what these ordered pairs are. Check out, here is the ordered pairs. Stern, 95. Cal, 95. This is a set of ordered pairs, and there's no specifics about what these ordered pairs need to be. Okay? Definition of a relation, any set of ordered pairs. Now we can talk about that relation, and the ordered pairs include x values and y values. So there's a name for that. The domain is the set of all the inputs or the x values. Okay? So here my domain would be Stern, Cowell, Beck, Winfrey, and McGraw. All of the x values, all of the inputs. And the range is the set of all the output values, or the y values. Okay, so here my range is 95, 95, 90, 82, 82, just the set of the y values. Okay, hopefully those words are a review. Now we can step this into math, right? And we can talk about our domain and range. Still, we can label this. And I can say, here's my x values, here's my y, right? Domain and range. X values and y values, the domain and range. Now, what is a function? Because we use this word function all the time, right? And what is it? So a function is still the set of ordered pairs, right? A set of ordered pairs, but there's more specifics about those ordered pairs. It's so specific here that a function says that every x value corresponds to exactly one y value, okay? Every x value needs to correspond to only one y value, okay? Let's look at these two sets of numbers or words here and figure out which one of these is a function and which one is not. So notice these x values. Stern goes to 95. Cal goes to 95. Every x value goes to one y value. Stern doesn't have two y values, right? Stern only goes to 95. Cal only goes to 95. And that is true for all of those people. So this is a function. Take a look at this one over here. 95 goes to Stern. 95 also goes to Cal, right? Like there's something wrong right away. This x value goes to two y values, so it's not a function. Okay, and that's the way that we are going to be identifying, and always functions. Every x value needs to correspond to exactly one y value. So here again we have in numbers in ordered pairs. If these ordered pairs were in a set of numbers 2, 3, and 2, 5, it's not a function because notice 2 has two y values, 3 and 5, so it's not a function. Okay, so we can also practice this here, and let's take a look at B. We don't need to do both of these. Let's just take a look at B, and I'm going to determine, first of all, let's talk about the domain. Okay, so the domain, I just will write D colon. And we can use these squiggly brackets to list all the values in my domain. So I need to go through and look at all my x values. I have 6, I don't need to repeat it, 8, and 9. Okay, that's my domain. My range, I'm going to go and list my y values. 1, 2, 3, and 4. There is my range. So now I need to look at that and determine, is this a function or not? Well, notice right away, 6, 1, 6, 2. 6 has 2 y values, so it is not a function. Okay, take a look at the x values. It can only go to one y value. There's also a way to determine functions or not functions based on looking at a graph, okay? And this is super important, and it's called the vertical line test, okay? A vertical line. If we draw vertical lines through a graph and it intersects in more than one point, then it is not a function. Okay, so let's look at A here. If I draw a vertical line, it is intersecting that graph in 2 places. So it is not a function. Not a function. And think about it, right? There's that x value right here. This x value has 2 y values. So that's exactly proving the definition of a function wrong. This x value, whatever this random is, has 2 y values. Not a function. If I drew a vertical line through B, everywhere, it's only going to intersect my blue graph once. So this is a function. Okay, so the vertical line test is super helpful and quick and easy to figure out if a graph is a function or not. Okay, let's talk about increasing, let's talk about domain and range again. We'll keep talking about domain and range. So remember, domain and range is a set of all inputs, x values. Range is a set of all outputs, the y values. We want to be able to look at a graph and determine the domain and the range. And how we are going to do that, we are going to use something called interval notation. Okay, and hopefully that's a review. Interval notation. An interval, it's like if somebody says, pick a number from 5 to 20. That's an interval. Somebody's giving you a specific area of all the numbers to look at, 5 to 20. So that's what we are writing. We are writing the interval. We always go from least to greatest, just like I just said, 5 to 20. And it is based on whether we're doing the domain or the range, right? If we're doing the domain, it's going to be in terms of the x values. If we're doing the range, it's going to be in terms of the y values. The interval notation could be using brackets, or it can be using parentheses. Okay, if we ever are talking about infinity, something that's going on forever with arrows, that's when infinity would be used, and that's when we would use parentheses. An open circle would also tell us to use parentheses. A bracket we would only use when there's a closed circle. Okay, closed circle means the number is included on the graph, and an open circle means that number is not included. It gets really close to being on the graph, but to being in the function, but is not included in this set of numbers. So let's try. So here's this example. If you look for the domain is x value, so I'm looking at my x-axis. I think about the furthest thing on the left, that's -4. Furthest thing on the right, that's a +2, which is why my domain goes from -4 to 2, left and right. Okay, so think about domain, left and right. Range, I know I go up and down. So the very lowest part on my graph hits right here at 1, and the very top of my graph hits right here at 4, which is why my range goes from 1 to 4. Okay, think about these directions, left to right for domain, up and down for the range. So let's take a look at this example here. Letter A, okay? If I was doing my domain, the very left domain is x values. On the very left is -3. It's an open circle, so I'm going to have a parenthesis, comma, the greatest x value that's going to be on this graph, and that's a 2. And it's a closed circle, so I use a bracket. And there's my domain. It goes from -3 to 2. It's never going to come over here to 5, right? I had to cut it at 2. Same thing over here. It's never going to come to -5. We cut it at -3. And then my range, I go top to bottom. So on the very bottom of this graph, the y value is 1. It's an open circle, so I use a parenthesis. And then the very top of this graph is at y value a 2, and it's a closed circle, so it's a bracket. Okay, there's my range, and that's all we have to do. Okay, look again, left and right. for my domain and up and down for my range. Now this B is a little bit trickier, but we can do it. Okay, the furthest thing to the left, take a look. Okay, the furthest thing to the left, notice, is that arrow, right? That arrow for my domain means it's going forever in that direction. Well, what number is going to be forever in this direction? Negative infinity. Okay, negative infinity. It's going to get super, it could be negative a million, negative 2 million. Negative infinity is my smallest x value because of that arrow. And then notice the furthest thing to the right, it's going to keep on going to my x value of 4. Closed circle is a bracket, infinity is a parenthesis. And that's my domain. And then my range, the very bottom of my graph, happens here at the y value of 0. And then the very top of my graph, I want us to look at this. I do see that that arrow goes this way, but notice it's also slowly increasing upwards, and it's going higher and higher and higher towards infinity. And that's the top of my range there. Okay, so that's why my range is 0 to infinity. Notice my brackets, notice my parentheses. Okay, great work, guys. There's one more video that you guys are going to watch. Super important to watch. So after you close this one out, go ahead, click on the other one. That one will be a little bit shorter. Awesome job, guys.